Hi, you are welcome in the online learning in PG program in GIS and remote sensing, which is running under the Department of Geography and Environmental Studies, College of Social Science and Humanities in Adigrati University. So in this slide, we'll discuss about the data analysis in GIS. Hi, in this video, we will discuss about geostatistics. And here you can see that the arc map is open. So first, what is geostatistics? Uh, Geostatistics in its original usage refers to the statistics of the earth, such as geography and geology. Now, geostatistics is widely used in many fields and comprises a branch of spatial statistics. So, if you want to practice geostatistics with the help of ArcMap, then you need to take geostatistics tool here, Geostatistical Analyst. But be sure that you have checked the extension. Here it is, your extension Geostatistical Analyst extension should be checked. Second thing is you should have the data, and here this is the point data. You may have point, polygon and line data also, but here I'm using this point data, and this point data shows the rainfall during January in Tigray region. So if you will see your data here, this is only 1 month rainfall data. One thing you notice, the data is given in point form. So if this is point 1 and point 2, so these values represent the points only. But what is in between these 2 points? For that very purpose, we use geostatistical analysis tool for our analysis. What we do with the help of this tool, we use this discrete data and we create continuous raster surface. So with the help of raster surface, those areas where points are not given, you can understand the rainfall, the probability. That will be the probability. Okay, this is 3.94 and this is 4.27. Then as you will move from 4.27 towards 3.94, then how values will decrease. And from here, from 3.94 to 4.7, how values will increase. So the the power of increase and decrease is in your hand with the help of this tool. You can minimize that power, you can maximize that power. So it's a very useful tool which you can use for your studies, for your research work, and for your maybe data analysis. So let's see here if you will go through this. And another important thing is you should have stop editing mode. If you are at start editing mode, then this tool will not work. You see, this is invisible here. So you should be in stop editing mode. So what is the basic purpose of geostatistical analysis? Just here I will demonstrate. Later we will discuss one by one in detail. So the basic purpose of geostatistical analysis tool is to create the surface with the help of point data, or it may be line data, or it may be polygon data also. So let's do it for only some small area. I will select this part here, and now you can use geostatistical wizard for that. So let me give you a brief account of this small window, that is geostatistical wizard. In okay, so this interpolation technique here, this is interpolation technique, is divided into three parts. Basically, there are two major parts. One is deterministic method, and second is geostatistical method. So what happened? What is the difference in between these two is uh, deterministic and geostatistical methods are here. Remember, deterministic interpolation techniques create surfaces from measured points based on either the extent of similarity, that is the inverse distance weight. So if you are using in IDW, then it is based on the similarity, extent of similarity. As you are moving away from the point, the weight of that point will decrease. Okay, similar values are together. Okay, extent of similarities. And here radial basis function, it may be on the basis of the degree of smoothing. So in deterministic method, uh, this is here, but based on the similarity and the degree of smoothing. But here, if you will see geostatistical method, we can call it Kraging also. But the important feature of this geostatistical method is, as here statistics word is given. So Kraging utilize the statistical properties of the measured values. So geostatistical techniques quantify the spatial autocorrelation, right? Spatial autocorrelation means here space, the distance in between two points or among the points is included, and that is the very important part. Here, geostatistical method helps you a lot in your research work. It will give you the results so you can create your surface, or you can predict the data, and you can uh, develop the layers which shows the prediction or something like this. Here you can see like this. So in geostatistical, as you will move on taking to any data set, then here you have to transform your data, okay? Because here statistics is involved, so it requires your data should be normal distributed. There should not be clusters. So if there are clusters, more values are concentrated on one part, so it will affect your result. If your data is not normally distributed, it will affect your result. So the geostatistical techniques are the techniques which you have to focus more on the nature of your data from the viewpoint of the statistics. So here, just for the mm, demonstration, like the basic purpose of the geostatistical wizard is to use this discrete data and to develop the continuous surface. Let me take the deterministic method, then inverse distance weighting. Here, this is the rain, and make it next. All these uh, controls are very important for creating or developing the surface. All these controls we will discuss one by one, and here just to show you the basic purpose of geostatistical analysis is that it creates the surface. Here, let me make it finish. So as you can see here, it has created the surface for you, and in this surface, as you are moving from 4.38 towards 5.87, so the values you will find here, you will find this is 4.38 value here, okay, 4.38, and here if I here 4.38, okay, 4.47. So in IDW, inverse distance weighted, as you will move away from the point, its weight will decrease. So you can understand this is 4.38, here 5.87. As you will move towards 5.87, the values will slowly will increase. Okay, here by default the classes are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 classes are here. If you want to give more classes, you can give more classes also. So if you want to classify into more classes here, you can give more classes also. So as you will give more classes, you can see the more differences. Here I have given 20 classes. If you want to give 30, 50 classes also, you can give 30, 50 classes. Then it will give you more classes, or it will give you more distinct values on your map. So another important thing is when you are using geostatistical analyst tool, your layer which you have produced is highly dynamic, and you can change the parameters also, like method properties are given here. Okay, so here if you will change all these parameters, okay, if you will make any change, then if you will finish, the change will appear you here. So it's highly dynamic, no need to create another and another new fresh data set. One data set is enough. You can manipulate the values here, and you will see the difference in the result. So here, okay. So we will take in this series we will talk about the geostatistical analyst, and the major part will be like first we will discuss how we can explore the data. We'll talk about the histogram, normal, Varana, trend analysis, semi-variogram, general QQ plot, and cross variance. And it is very important, very important. It will give you, big insight of geographical or survey data, so you can understand that what technique you should use by looking the nature of the data. Okay, I mean, here there are many techniques here given for interpolation, but before adopting any technique, you must have the insight, the nature of your data. Okay, with the help of this data, you can understand that which technique is most suitable for creating the surface. So in this series, first we will talk how we can explore the data, we can understand the nature of the data. Thereafter, with the help of this wizard, we will discuss one by one the methods, and we will discuss with suitable examples. So I will prepare the next video related to the data exploration. So thank you so much for this video.